I'm Sridhar Kota, Professor of Mechanical Engineering at the University of Michigan and also the Director for the Compliance Systems Design Laboratory. When you think of a robot, like the robots of the 1980s and 90s, where you have these gigantic arms with motors and the robots are caged and fenced, these are the assembly robots that you think of. Today we want robots to be not replacing human operators but working with humans, whether it's on a factory floor or working with the surgeon assisting the surgery or working with soldiers. These robots have to be safe for human interaction. Designs in nature are strong, but they are compliant, they are flexible. Whether the way the tree bends in heavy winds to elephant trunk to octopus, for example, it's highly dexterous and it has no joint. It can move gracefully and vigorously through what's called Elasto-Fluidics. And that's what the inspiration we took to create new design methods for what I call soft robots. We started looking into what's the best way to arrange fibers and fluids to get intricate mechanical motions. Soft robots are by nature compliant, they're flexible, they're not rigid, and yet they provide highly sophisticated mechanical motions. It's made of elastic polymer and it has fibers wound on it. So you have sets of fibers wound at different angles. By changing the orientation of the fibers, we can get different kinds of motions and we can use them for a variety of different applications. This was the eureka moment for us that we discovered this whole new range of motion possibilities by having a simple soft tube wound with fibers at different angles. In one case, when you pressurize it, you can get simple extension and compression. In other cases, for the different sets of angles, you can get a pure rotation motion. And in another case, you can get combination of rotation and translation, like a screw motion. If you have a third fiber, you can get helical motion. You can take these and combine them in a parallel, and depending on which ones you pressurize, you get more sophisticated, more complex three-dimensional motions. I have other students working on different projects, but it was primarily Josh who discovered these ways of winding the fibers, different orientations, and creating these frieze. We developed these methods and also explored various applications, not only at the micro scale, but also many other applications in automotive, medical devices, and so on. We are barely scratching the surface of possibilities with these Elasto-Fluidic devices. The possibilities are many because we can generate not only a wide variety of sophisticated motions, but some of the motions that are not currently possible by other means. I'm hoping that people can look at these and think of many creative ways of doing many other kinds of things, and I strongly encourage them to contact us through Compliance Systems Design Laboratory website, and we would love to collaborate.